Herkese merhaba. Arman Bey,
Well, hello everybody. Arman is going to make his presentation in English, so if you need translation, well, you can get your devices, the headset, I mean. He's now saying it to Turkish audience. Well, he'll speak in English. We can wait a little bit. There's another panel at the next room. Storage is important, as you all know, energy storage. Now, the panel is about that, and that's why the room is very crowded. It's a bit unlucky for us, but otherwise, our panel is going to be really exciting. If you wish, we can start. It's 3:34. Yes. Hello, everybody. This is Osman. I come from EPRA Electricity Energy. I am the general manager. I am an electrical engineer. By the way, first of all, I'd like to thank TREP organization team for the invitation, and I'd like to thank our panelists in advance. And thank you so much, dear audience, for being with us. It's going to be a great panel because we have really valuable speakers with us, very valuable guests among us. First of all, before I introduce the speakers here, I'd like to make some introductory speech. Everybody here wants our share to increase in the grid, and in the roadmap which has been announced by the minister, we saw great targets for 2035. But when it comes to renewable energy increase, is it going to happen really? What do we need for it? We need safety and security in the grid. Otherwise, it's not going to happen in the renewable energy. Well, the targets in the renewable energy are dependent on the safety and security of the grid. If we can facilitate it, our way will be paved. Okay. So for the grid to work safe and in a secure way and to have renewable in an integrated manner, we need some technologies, right? But what are those new technologies? Well, that will be the title of this panel. We're going to be discussing these new technologies and how much does the grid need these new technologies? What kind of contributions should we create for these technologies integration? Of course, the development and the implementation of these technologies need certain policies, and we will discuss them. Well, you can see these wheels on the slide. It talks about policy, technology, safety, and security of the grid. And at the very end, it's going to increase the source share of the renewables in the grid. So the panel will be about this. As you see, we have our speakers, Polani Seifert is going to talk about policies today. And on the technology side, Mr. Arman will talk about HVDC, and Sefa will talk about EMS. On the new technologies, especially systems with storage, the systems that support renewable energy will be the topic of his speech. And also there are certain contributions of the renewable energy on the grid, and we will listen to our speakers. Kazım is from KYASH, and he is going to give us the perspective of the grid. Yes. First of all, I'll give the floor to our speaker. He's going to talk about the technology in the grid. But before giving the floor to our speaker, I'd like to mention HVDC road on our roadmap, which has been announced recently. As you see on the map, there's a new term, concept. We are not very familiar to this, HVDC. HVDC is a new concept to us. It is not available in Turkey, but this has been started to spoken in Turkey based on this new roadmap. Well, on this HVDC, there are long lines and there are many converter centers and there is a big infrastructure. So our expectation is that renewable can also contribute on the grid's growth. Well, in parallel with our panel's title, we will listen to some new insights about HVDC, the contribution of the HVDC, specific to renewable integration. We will listen to these details from our speaker, Mr. Arman. Well, you can introduce yourself, and yes, the floor is yours. Thank you.
Can I have the pointer as well? So thank you all. I'm very glad to be here back in Istanbul. I'm Arman Dervishkadic, and I represent Hitachi Energy. I work in the HVDC sales team. So today, as Mr. Bulent has announced, I will be speaking and I will be deep diving a little bit in HVDC technology. So first of all, I represent Hitachi Energy. So Hitachi Energy is a global player. We are a company which has headquarters in Zurich, in Switzerland, with over 45,000 employees, and we are spread over 90 countries around the world. We have several business units which we use to deal with grid automation, high voltage products, grid integration, and manufacturing of power transformers. We are serving different segments from transport and infrastructures, industry and utilities. We are offering different type of services, systems and products, and also we are spread over the geographies in a quite balanced manner, so between Americas, Europe, and Middle East, Africa, and Asia. In renewables, Hitachi Energy already has delivered over 25 gigawatt of offshore substations globally. We have over 25,000 transformers which are installed in wind turbines, and also we have recently commissioned the largest solar farm in Dubai connected to the grid. How we do that? We do that because we are collaborating with our clients, and also that we are working together to integrate their systems towards the grids. So today I'm here to speak about HVDC technology, and HVDC technology nowadays is becoming very mainstream. Already at global level we see more than 300 gigawatt of installed power across different geographies, but as you see in the map, nowadays Europe is one of the main drivers for it, and specifically the North Sea. It is a very fast-growing market, so it is growing 3 times faster than the world GDP, and we as Hitachi Energy are the global leader in this technology. So nowadays we have more than half of the installed base globally. The application of HVDC has been rising in the years very fast. So since the first installation happened in 1954, you see that the path was quite slow. However, from 1997, a new technology has been launched, which was the voltage source converter based HVDC transmission. And from then the application of HVDC technology has been increasing in a rapid way. About 15 years ago, we have installed our first offshore wind project connected with HVDC, and that is when this trend started to boom. And as you see in the map today, HVDC technology is widely utilized, and also that the trend is going much faster than in the past years. So there is a huge exponential growth in the utilization of this technology. So what we are doing to tackle this new expansion, we are trying as Hitachi Energy to expand our capacity globally. So already from 2020 to 2023, we have invested 3 billion in our basically supply chain and in our installed capacity. This year only, we have invested 1.5 billion and hired over 4,000 people to allow the energy transition to happen at the pace we need. And also we have announced in the years to come from 2024 to 2027, $4.5 billion more, which is very important to cope with the trend which I have shown earlier in the previous slide. So, HVDC, nowadays, it is based on VSC technology, that is voltage source converters. You see in the slide, we are inside of a valve hole, so you can see the very high level technological content of what we are doing nowadays. And you see also that this technology is widely applied nowadays because it solves several of the problems that modern grids are facing nowadays. So especially when we come to weak networks, we have the possibility to actively control active and reactive power. We have the possibility to stabilize the AC networks, and also in certain occasions when there is a need, we can also run the black start for power restoration. VSC technology also helps the bidirectional power trade, so it allows very fast reversal of the power when it is needed, and also it is a very good application for the integration of renewables. Why? Because the power and voltage control is very fast, and also the technology is very compact, and this minimizes the footprint. This is a little bit to show you where we are. So this is a technology outlook, and what I want to communicate with this slide is that already the technology has reached the levels to support the European energy transition. Nowadays we are focusing mainly on two standardized and harmonized topologies. So we speak about plus minus 525 kV in bipolar configuration, or plus minus 320 kV in symmetrical monopolar configuration. And what you see in the slide is that already the power ranges for these voltage levels are already above, from converter station perspective, than the needs of the present, let's say, applications we are seeing in Europe nowadays. And that is also in line with what I have understood was launched recently by TEIAS in terms of power and voltage ratings. What is also very important to mention is that when we speak about offshore wind, it is very important to mention also that we as Hitachi Energy are already cooperating since more than 15 years with the integration of HVDC technology with the platform suppliers. So in the past 15 years we have worked closely with each other in order to improve the efficiency, to reduce the consumption of the space in the platform, and also to have a much better ratio between the platform size and weight and the delivered power. So we can do that by compacted main circuit equipment, optimized redundancy, of course, no permanent living quarters in the converter station, and also layout optimizations. A little bit towards the future. So historically, HVDC projects were mainly built as point-to-point systems. Also in the graphics which you have shared a little bit earlier, we had mainly point-to-point connection from eastern Turkey to the west and to direction of Istanbul. What I wanted to highlight is that at European level already we have commissioned multi-terminal systems. So we have our first 3-terminal system in monopolar configuration, which is running in CMS project in Scotland. Also there is a 3-terminal in bipolar configuration, which is and has been announced in Italy recently. And also in the past month it was announced a huge multi-terminal development in Germany, which we are part of. And that is made possible also by the innovation and integration of a new technology in the DC field, which is the DC circuit breaker, which is one trend topic nowadays. So Hitachi Energy has launched its first prototype back in 2019. And now we are working with the German TSOs to develop a new prototype at 525 kV level. So time is short. I will just go in few recent references which I wanted to highlight, which are relevant for what we are doing here. So here we speak mainly about wind. So in the bottom left corner, you can see the TenneT 2 gigawatt program, which was a very important milestone for us because that was the first example of huge cooperation between suppliers and transmission utilities in order to identify the way forward. And in this case, it was announced last year a program of 12 gigawatt of HVDC project launched together with TenneT. So you see already with the European utilities, we are getting at scale and at speed, which probably will be the case for Turkey also in the coming years if the plan which was announced will continue. And also, again, since we are here in a wind sector conference, I wanted to highlight also the Dogger Bank project. It is in the bottom center in the slide, which is the biggest, basically, offshore wind project which was commissioned. It is a 3.6 giga project divided in 3 corridors, of which each is 1.2 with perfect, let's say, modularity and scalability. So it is a copy-paste of the same transmission solution to connect to the grid. So just to conclude, we as Hitachi Energy have, as you saw, a long history in this field. So we have the largest installed base. And of course, we are here to introduce our pioneering spirit. Anyhow, I want to highlight that what is very important is that we are doing that in cooperation with our clients. In the way ahead, and also due to recent announcements in Turkey, I want to say that we are ready to entertain the dialogue around the future expansion capacity. Thank you.
Çok teşekkür ediyoruz. Arman Bey bize
Well, we would like to thank you very much. Mr. Arman has talked about the very point that Hitachi has come in HVDC technology and what they have done in this area and certain agreements, projects that they have carried out. Well, HVDC is very attractive to renewable energy sector. Thank you so much for this information that you've provided. Now I'll give the floor to another technology solution producer company representative, Mr. Sefa. Sefa, can you please introduce yourself and can you please talk about what you do as Innovat Technology Company? What do you do in energy management system, in EMS system? What kind of solutions have you developed and what are the contributions of these technologies in the development of renewable energy? Well, thank you very much. I am the software director of Innovat. This is Sefa Keleş. Innovat provides turnkey energy storage solutions from engineering to production to installation and sometimes to commissioning. We are present. In the last 4 years, we have been working on energy storage, and this is something that we have been doing in the last 4 years. It's nice to see you here today because we are not going to define the very beginning, but we will talk about the very benefits of energy. Well, it's kind of interactive speech. I'll show you how this EMS system works and what should be the maximum capacity of it. I'll talk about implementation areas of them. Well, the time is not very long for us. If you just let the floor for me, I'll talk about this topic till morning. I'm an electric engineer, by the way, but I'm also interested in software. So for long years, I've been developing software. So we've had a chance to develop our own software system. So this is a great value in our value chain. This is a great part of the system because without energy management system, you can't use storage systems with full efficiency. And if you want to integrate them with renewable energy sources and at another level of efficiency, this is really difficult. So, Mr. Osman, energy management systems are like the very centers of this systems. Energy management systems will be at the core of renewable energy sources and integration to the system, because with these systems you can make use of them. Energy management system is not only about softwares, it has hardwares and softwares. Well, all in all, it's a system by its definition, and it is integrated with all the hardwares on the field. It's like a SCADA system that you are familiar to. It has its special name, but it's very similar to SCADA systems. If you wish, I can show you, and we can have a rather interactive way, because seeing certain things is better than listening about them. Well, you can see them on the screen. Everything that I'll speak afterwards are from the live systems. In 5 seconds, in each 5 seconds, live data is received. You have to be managing more than one energy storage systems. It could be small energy storage system, but when these small systems are gathered together, it becomes a huge system. So if we can utilize those small separate systems as a single system, you can get great benefit, virtual power implementations. On top of this EMS, there is another EMS system. There's a part of this EMS on the field, and there's another part of it which is located on the cloud. Well, that part is integrated to all systems on the field, and it can make us to manage everything from a single center. This is from the cloud, by the way. We currently have 4 energy storage systems in different locations in Turkey, and we can see live situations of them. Well, I'll make an active example later on, but roughly speaking, let's see what this system is all about, because all the pages later on will be much more meaningful. Active reactive power output outlets. As we all know, the storage systems give and take the active reactive power at the same time. They can work on 4 quadrants of the power simultaneously. Well, they can be really fast, like in the milliseconds. Great flexibility, and in terms of renewable energy efficiencies, it can provide us great advantages. And when you talk about storage systems, I'm sure you speak about them, but this is one of the main usage areas. For example, with your installed power, if your connection power is less than your installed power, the part that you can't produce in the same way could be stored and could be sold later on. If there's imbalance or inconsistency because of the profile of the renewable energy sources, it could also be eliminated thanks to this. Renewable energy sources might not work in certain times, and it can help with them. Well, it has numerous benefits, and those benefits could be managed with EMS. For example,
now let's have a look at one of the systems. I would like to click on one of the meters on the screen if possible. So let's enlarge the screen a little bit, please. So here it can be called as peak shaving. This is just a practice. Here we can see an example of that. All the data is created to actually alive based on what happens on the field. You see this line, just think of a renewable energy plant. It might be a solar plant maybe. It just represents the power of connection, and the red line just shows the installed capacity. There are moments that we generate more than our capacity of a connection, so sometimes unfortunately we waste it. If we are to have a storage system, for example, then we wouldn't have wasted it. because we would be storing the difference in between these two lines, because the red color shows the installed and the green line just shows the connection line. This example is actually for the individual storage. Transformer's capacity as well is considered as important in here, so it is applied as well on the solar panel by one by. Energy management system is not only managing the field, so you can consider it as a SCADA system. If we are to use it efficiently, and if we are to use as well this, and we will do this integration in a meaningful way, then it is really important to control the solar and the wind. I've shown you a graph. And for you to just maybe produce over capacity, you need to remove the limits if possible. And if the batteries are full as well, you have to just return the limits back to their originals. So that's why you need a system that can manage both, and it is called EMS. So for your name, it is integrated on to your system on the field, and as well it can control newly purchased energy control system. It can store your maybe over excess capacity. If you generate less, then you can use the battery directly, so that you will do a stable generation, but it has to be integrated on the field. So when we say energy management system, we wouldn't be only managing the systems on the field, because if this is the case, we cannot get sufficient support. So these are all individual, by the way, individual storage systems these are, and by the way, we have to just manage them by bulk. In Eskişehir, we have a system. Now it is doing the discharging. The reason why is it just corrects the power factor. So it just looks at the required reactive as well amount. Let's make a live example at the moment together. Energy storing systems. Well, I'll tell them to decharge for 100. Let's see what we will see for the discharging. I gave the instruction, by the way. It gives quick reactions, very quick reactions it gives. We will see the result. It has already started. The system in Denizli is discharging with 100 kilowatts. So 100 kilowatts discharging. This is what we say as an instruction, but it does not do it. It's a good example, because when we say energy management system, it does not mean only software that only just follows your instructions, but it has to also control the limits on the field, security as well, controls and restrictions. I give the command of discharging 100 kilowatts, right, for Denizli city, but it cannot exceed the 25 kilowatts on the field because it's not safe. So that's why it just stays there at the 25. Now I am changing the mode to charging. And now I am charging it with 100. You will see the result, but this instruction that I'm giving can be implemented, can be used for any type of installments in Turkey, no matter where they are located. Within 300 milliseconds, actually it works. We have a unit in Denizli. Now it is charging with 100 kilowatts. The other one is charging with a 4.7, and the other one is charging with 29 kilowatts. So the conditions are important here. The conditions of the field are taken into account. In the battery of Denizli, we see that there is low battery. That's why it is charging with full capacity. However, in other regions, the batteries are already full, almost 90. So that's why it's not charging with full capacity. So this system should be protecting our batteries as well at the same time. And this is what it does here, so that we can have a healthier life for the battery, because the batteries are the most expensive parts of the system in the end of the day. We have to protect them. So virtual power plants is what I am doing at the moment. One of the important things is that for the grid safety, energy storage systems are really important, because in case of a blackout, the grid should continue to work, so it enables you to make black start. So for doing it, especially to do it in Turkey, we need a very capable energy management system, national scale or private scale. It has to work for the private customers and also for public customers. So in this demo, we see it works. The amount of the power we need can be supplied by the system, and also we can do the black start. The system is capable of doing it, and it is also really important for the supply security. These are all individual versions. So how about the solar energy integrated system? What would we say about this? Here, what you see is the maximum level of the system can reach out to. On the left side, you would see the yellow line that represents the sun, and also we see the rest. And this is the installed system. This is, by the way, a live real data. The blue color shows the grid, and the green color represents the energy storing system. In this example, we also have car charging stations, because the topic is related as well to this, the car charging on the equipment. The amount of the equipment, it can be an energy source or load, they have to be controlled also, and should be followed, so that we can earn more and spend less. So what we do here is this exactly. We produce on the sun, and we try to make the maximum money. When we get the car, also we can supply to the car chargers with the minimum as well pricing. We can just increase our profit. There are parameters, so full automated system functions and work accordingly. So the system is integrated with the markets. You also see the prices for the market. Energy management system knows the prices, and if necessary, the solar generation can be just assumed, and the car charging customers and the clients, by using the as well booking a system, it knows and follows the times and the calendar when the client will come and go. This is what it does. The system works for the maximum profit. So the flow of the energy is being controlled by the system itself. And here you see the chart. I hope you see it clearly. For 1 watt per hour transfer, well, it is recorded. By the way, let me touch upon one more thing. Energy management system is valuable with its equipment, and energy analyzers are the most important equipments. That's why we need high quality, high sensitive energy analyzers. So it is a must. It's an obligation for this work. Even if it is one actually watt per hour. It is also recorded. Here you see a car. You see what it is done. We have charged a car repetitively. Comparing to the current conditions of the market and as well comparing to the benchmarking to the energy pricing, this car is charged by this system. The car comes and is connected to the system, and this storage is supplying to the car. Sometimes there is a confusion. The energy which is generated by the solar is being stored within the unit, and it is for free. This is the confusion. No, it's not for free. It is actually an opportunity, because if you are to sell it, if the energy costs for 3,000 Turkish lira, you are to make 3,000 Turkish lira. But if you store it instead of making cash, then it is an opportunity. So these are all very detailed calculations that you have to do. For example, 30% of the battery, if it is filled with 3,000 Turkish lira of energy, and then when we are to decharge it, then on the top of the 2,000, if there is an extra price, then we are not charging it, not to make any actually lost. So you can maximize your profit by making a very sensitive calculation. It can be only done with the energy management system. It is beyond SCADA. So SCADA only controls the equipment, but this is beyond this. It is making a benchmarking, making estimations about the generation and the productions, and it offers optimization of the profit. And at the end of the day, what we do is energy optimization. So this is all I was planning to explain. Thank you very much for listening to me. Well, thank you very much, and also thank you very much for the live demo. Virtual power plant, yes, we keep hearing about this. However, for the first time, I see it. There is only one single actually source for it, and it's great that you have shown it alive. Storing has four parts of active energy. It can pull and withdraw energy. It supports the energy. It's a great opportunity. This is how it looks. And all the examples that you have shared with us, when we think from the perspective of an investor or maybe a regular user of the electric car, well, and these are the examples for them, I believe. However, the storing systems on the grid, what does it mean? Well, on this issue, I think Kazım will share his insights because we have heard about the roadmap of the renewable, their important objectives, and Mr. Arman has talked about the HDV roles. So how about the storing? We know the technical support it can provide. So now let's hear Mr. Kazım. This is an aggressive, actually, objective for the renewable energy. How about our capacity on the grid? Would it be capable of handling it? Is it enough? Do we need more? So could you please share your insights from the perspective of the grid, please? Thank you very much. My name is Kazım Şen Ocak from PEH. In the Department of Planning I work. I have been here since the morning, and we have heard many presentations on the morning. Our ministry has some clear objectives for the 2035. We have now a 31 gigabyte for Hessen gas, and well, it is going to reach out to 120. At least this is the plan. So 2035, would be 510 terabyte hour. Right now it is 350 terabyte per hour. Within 10 years, it will multiply by 1.5, and 1 out of 3 would be coming from the hydraulic sources. This is how it is planned. As TEİAŞ, our main purpose is to focus on 120 gigabyte and integrate it into the system successfully, as Mr. Osman has said. For a successful system integration, what do we need? Let's have a look at the details. The first pillar would be the plants and make them be communicated with the systems, because there is the transferred energy and it is really important to carry it from one location to another location, and we need energy corridors. And you have to use the transformers, of course, by not creating maybe a narrow down within the factory. By using maybe the intermediate lines, you are supposed to do the transfer. And the second dimension would be, many people maybe skip, just make this network to work in a healthy way. Wind plants or solar plants. Within the system, it has to create a good balance, and especially when we consider different hours, the generation and the consumption balance and the differences should be taken into account. It can be per hour, per like every 50 minutes, or weekly or monthly. It can be calculated, but we need a balance. The energy analysis for 120. Yes, we carry out such studies. As the institution, we see the changes during the day. We have annual simulations that we do. And on these simulations, we offer some solutions to the certain problems. The biggest challenge is that the consumption level is lower than the generating capacity. This is the biggest challenge. For example, during the lunch time, 55 gigabyte of production capacity you have. However, on that day, it is a spring day, and depending on the weather, you don't have a demand for the electricity usage. So it's not a busy day. So this is an overplus. Either it has to be stored or it has to be limited. And it may cause the loss of value. So this is going to be the first priority of storing. EMS system that you have shown has a larger scale already. So we have seen actually many other examples on the system levels. Solar energy, if it is not on the desired level, it has to be disposed. Or if there is maybe a storage, it can be stored. And the second issue is about the reserves. The variations of the wind or the sun should be covered. If there is a cloud passing by, for example, then it may cause an impact on the system. And if this is the case, there can be an increase on the reserves, and it can be stored if the storage plants are to progress, of course. And the third pillar is during the lunchtime, over consumption and over production. Yes, we see a 0 point. However, the natural gas plants can replace with the solar during the lunchtime, which means the flexibility of the grid. So these are the three main important parts. Yes, we know that there is the tension and also the angles and the systems working and the connection criteria, improvement on the systems, and as well improving the site storing services. These are our actually work titles. We are now working on these different titles regularly. We do revise some projects and we try to figure out maybe some new solutions to these question marks. So Asia has some proposals to these needs, but for the future we need further policies and regulations, I believe, because we do not need anymore the traditional methods of producing, I believe. So it has changed. In the future, we would see that the plants are going to make the generation, and according to the generation, you would have to create a demand. The generation is now independent of the consumption based on the natural sources, and now we have to adopt the consumption level to the generation, and your level of electricity will have a superior dimension on that regard, and there would be probably different actors. Other actors are required, and a new maybe market style is required for this. Electric should be consumed when it is generated, and this is what we expect for. As Mr. Sefa has said, well, what I would say is that foraging in that regard is really important. When the sun is like really shine, for example, this generation can be intensified. The pricing, of course, is important on that regard. The pricing signals should be taken into consideration, and the consumption should be minimum. So the demand participation, when there is a high pricing, you might cut out of using the electricity, can be an option as a user. Especially for the virtual power plants, if we are to integrate it to the consumption, even if we are to combine storing with the generation and act as if we are maybe a larger unit, then we can search for alternative solutions. These are all inputs for our system. We cannot integrate all these solutions into our grid right away. However, such alternatives can really let us to make maybe a higher capacity grid, because as an institution, we only provide site services, the transmission as well lines or transformers. However, electricity policies are related with different actors. So,
ulaşım sektörünün
especially the transportation sector will be electrified. Electrification is very important because 125 gigawatts of renewable energy should be consumed. Your primary source is dependent on natural gas, and heating sector should be electrified. As parallel to the targets of the renewable energy. Well, there could be different options for the potential of the electrification, because I do communication planning. I don't have other expertise. Well, all in all, renewable integration is not only dependent on the transmission allocation of TEİAŞ or not. Installing transformers, there are more issues. Well, we need a total solution. With respect to HVDC, I have to mention this. Currently, in HVDC technologies, we use them to make the system connection available, because in high power energy, currently, we cannot reach certain levels with AC. That's why HVDC is our own agenda on our technology pipeline. So if you have questions later on, I can answer to them. Well, thank you very much, Kazım. Kazım has touched upon important and interesting issues. Now we are switching from consumption to production, and renewable is triggering it. This perspective is very important. Of course, TEAŞ makes investments, transmission lines and transformers, but it's not going to be sufficient. Maybe they are going to make investments on HVDC and storage systems, but one way or another, we have to have different policies to have different solutions. Well, at this very point, I'd like to give the floor to Pauline. Pauline, Germany is one of the pioneers in renewable energy, and you closely follow Germany. And what would you like to say about our targets? Because it's something certain that we need policies. What kind of examples would you like to give us in those countries? What kind of policies have been created? We would like to listen to you. Well, thank you very much. I'd like to thank you so much, Bülent Bey, first of all, for giving this opportunity to me. And I'd like to also thank Trip. By the way, I need to define, I am a German. Sometimes I might not speak very well Turkish, but I'll do my best. In the last 5 years, I've been residing in Turkey. In the past, I was working in German and Turkish industrialists' chamber. I was responsible of the energy sector. I think these energy projects are very important for Turkey and Germany politics. I'll talk about the German policies and how they have been developed, and sometimes there are certain negative situations, especially with respect to energy transformation. There could be certain negativities. We are all aware of this situation after Russian-Ukrainian war. Germany as a country was very much dependent on Russian natural gas. That's why German industry faced big challenges. But yes, later on I'll talk about them. Okay, so I'll show you the emission rates and our targets. As you can see, in Germany, the energy sector contributes emissions significantly. Emissions in these sectors should be reduced. This is our target by 2030. Taking 1999 as the basis, emission reduction will reach 65%, and we are chasing after this target. We're not sure whether we'll reach this target or not. This is a question mark, and everybody speaks about this. But still, the German government insists on this target. These are current data, by the way. This is the installed capacity of Germany. As you see, biggest energy sources are solar platforms. I was born and raised in Hamburg, and it was not very shiny, by the way. But how did it happen? You might ask this. There comes energy storage. Energy storage capacity in Germany is more than 16 gigawatt hour. And this is something that we explain to the investors. When you want to make solar in Germany, you have to think it with storage, because in Germany there is a liberal energy market and there is this arbitrage of it. Well, with energy trade of it, with the arbitrage, you can sell it on the market, and there comes wind after solar, especially on the north area. It's really windy. The southern parts are not very much full of wind, but On the grid, of course, there is a challenge for us because the majority of the wind comes from the north, but the industrialist area are generally on the south. So how I can transport energy in a green way to these different places? Well, it might be a challenge in Turkey, by the way, because in Anatolia there is big energy production in Turkey, and how can it be transmitted and transported to Istanbul, Izmir, or industry zones, considering green transformation and electrification? And also, there comes natural gas in the third place. Natural gas is used as base load in Germany. We have announced industry strategies. In the short run, in 3 to 4 years, 10 gigawatts of natural gas power plant is going to be installed. I'm sure there's going to be more than this. Approximate target is around 20 gigawatts. Natural gas, is it green energy? No, it is not. But the government targets to transform it. What does it mean? After 2030, this is going to be turned in a way that it could be worked with hydrogen. This is a big investment, yes. For that reason, German government supported it with a big grant, and the tender was opened, then it was closed. Inshallah, hopefully, the projects will be installed very shortly. This is the electricity production in Germany. As you see, by the way, this is from 2023. As you can see here, green energy share is growing. It's more than 60%, and there is also the fossil fuels. They are still big, and there is a small portion of nuclear, but it is not available anymore. Yes, maybe it's an energy policy. This is an old decision. Along with energy crisis, current government did not think that it could be changed, but we decided that nuclear power plants would be closed and more coal would be used. Maybe it's a kind of dilemma, right? According to some people. But still, Germany aims at reducing phasing of or phasing out fossil fuels. We have interconnection or interconnector. European market is an integrated market. It is not like Turkey, because we can always make trade with our electricity, and, for example, we can import nuclear energy from France for a while. Some people might say this, how can it happen? Isn't it a dilemma again? Because in our country, we have closed nuclear power plants, but on the other side, we import nuclear energy. It is in European Union borders, of course. Regulation and integration there will be even much more advanced. There was a meeting with EMRA, and it was also discussed, both technically and on the regulation side. European electricity and energy markets will be much more integrated. And last but not least, I'll show you the green energy expansion targets of Germany. As you see, by 2030, 250 gigawatts solar energy has been targeted. 30 gigawatt is for offshore, and we've listened to good examples already. And there's 115 gigawatts of onshore in our portfolio. Well, how can we realize this? Well, to be honest, this is 2025 now, and already, and I can say this about my own culture. Maybe the Germans are very powerful in strategy areas, but sometimes on the regulation side, when it comes to permits, durations, we can have certain problems as the German people, and I'd like to talk about this. Well, generally, when we talk about green transformation, we can talk about different issues like technology. I have never mentioned hydrogen, by the way. Hydrogen is a different topic. PTSD is a different topic. And Germany wants to reach 10 gigawatts of capacity by 2030. But how can we bring this technology together? Our government aims at leading the other countries because we have hydrogen strategy certificate, and also international collaborations are important because in Germany hydrogen cannot be competing with the current electricity prices. So Mr. Yusuf is already here, and we do not know the roads, how to go there. Maybe there could be certain advantages or opportunities with Turkey, and decarbonization activities are also important. Well, yes, generally speaking, with respect to green transformation, as Turkey, or we have some targets like economic efficiency and supply security and safety and ecologic compliance, because we have net zero target as well. How to realize this in a sustainable way? This is important to us. And investments, technologies, markets are to be developed according to this. On the policy side, let me mention what we have done so far. Well, in Germany, there is big uncertainty going on. PTX investments with respect to hydrogen investments, there are certain domestic and international companies which are interested in hydrogen, but they are a bit hesitant because regulations are not very much certain. Both Germany and EU have not issued something certain yet. That's why, as an investor, you might have certain reservations. Additionally, yes, we have technologies. This has been also spoken today. Our technologies can be expensive versus China, and delivery time could be a bit long. But sometimes, yes, companies are challenging us. And this is something that I see in Turkey. By the way, as a company, in terms of business development and R&D, we work very hardly in Germany and in Turkey. We act as a bridge in between these two countries. Off-taker side, like there's this matchmaking side, is a big challenge for us because no investor makes investment on hydrogen without making things certain as an off-taker. In Europe, projects are advancing. There's Hydrogen Bank, for instance, HD Global. There are certain incentive programs. They conduct their projects But unfortunately, there is a kind of slowing down. But this topic is very crucial between Turkey and Germany for the collaboration side. For the exporters in Turkey and Germany, CBAM is important. We have to create alternatives. And German government gives significant supports like grants, incentives, and also, like I mentioned, for the energy collaboration partnerships and bringing partners globally. The German government aims at developing projects because without materials like hydrogen, we can't decarbonize our industry. Last but not least, let me check my notes. So, yes, carbon market. Carbon market is a big issue, as you all know. Mr. Minister has also mentioned it. Carbon market, as far as we see in Europe, I don't want to say it as a success story, but this is a market mechanism. Well, there's already a market created, and as the prices of the emissions have increased, I believe that the efforts of the reduction will be increased. Because as the minister has mentioned, decarbonization and green transformation activities will be financed. It's a big contribution for the markets itself. On the finance side, our industries like going to be motivated for emission reduction. Yes, that's it from my side. Thank you so much. Well, thank you very much, Paulina. Thank you. First of all, thank you so much for speaking Turkish that much fluently. Thank you so much. Is it 4 years? 5 years. 5 years now. In 5 years, you've spoken very well. Your grammar is really successful, very fluent. Thank you so much. And yes, we still have 20 minutes to talk. So I'll give the floor to our audience. Perhaps you might have certain questions. Yes. Do you have questions for our panelists? Maybe I can ask questions to our panelists. Maybe you can think about questions and maybe something pops up on your mind and you can raise your hand. Well, let me think. I want to ask a question to Sefa. When you talked about this example, the battery in Denizli was on 20 kilowatts. It was a good example. EMS is a tool about what we wanted to do, and this helps us to take smart decisions. But storage systems is very sensitive to heat. As you all know, EVs sometimes have explosions, etc. They are really heat sensitive, and cooling is really important for them. Is storage systems not always available? Is it a big challenge? Because we want renewable energy share to be increased in the grid. We want support, of course, and we want them to be available. But battery management systems, can they be a challenge for us? Is there anything that you want to say about this? Well, thank you very much. It's a great question, of course. And I'm sure that everybody is going to be much more enlightened. Maybe in this example that I wanted to give, I might have misexplained myself.
We have a unit that is working in Denizli city. Let me just share an example. There is a transformer which is for the 400 kV, and we have an installed power there, 250. There are other lots in the area, and the transformer, power is certain. It is 400, right? So the institution that owns the transformer, will go into the container on the storage. There is a screen touch display, and they decide somehow for a reason that they would like to charge their batteries. So in this example, the energy is supplied directly. We receive it via the transformers. However, the neighborhood's actually load is around 350. So in this scenario, any operator, if they would like to decide, for example, charge for 250, there will be an electricity cut for the neighborhood. So we do not want to experience this. So that's why you should know very well the neighborhood. You need to know the maximum capacity of a transformer, and you have to know about the instant load. And if there are other conditions, you have to know it, such as the warmth of the batteries, for example. If the battery has already completed one complete cycle and you have to wait for a while, for example, then you have to know all about this. And if necessary, an instruction given by us should not be followed, and it has to be really safe and secure. But it wouldn't mean that in a case, if we need, we will not use this energy storage system. No, this is not what I mean. The energy storage systems, yes, they are serving for any purpose, and they do not require repairing, for example, that frequently. We have been working in this area for the last 4 years. We have tested it many times and worked for long hours. So that's why I can say that they propose a full service. However, there are things that you have to pay attention. And as you cannot manually pay attention to these things, you should have a system that will pay attention to all these requirements automatically. And by the way, we do not have a BMS system. BMS main control and protection functions, yes, they do exist. However, beyond that, it requires also more protection systems, and the energy management system would be your friend in this case and a scenario. If you have a good energy management system, then it would mean that you are protecting your investment, and you will just make the system work. So it will work all fine. Thank you very much for these very valuable points. Availability is something that I'm really curious of. So it is really a great example. 4 years of experience is quite enough, I would say. I'm glad to hear it. So EMS and BMS, these are supporting one another. They have to be designed very well. So in Turkey, on the level of technology, we have firms, companies that are giving this service. So it is a great advantage. So we are in a good level, I believe, a world scale. Thank you very much. Do you have any more questions? Meanwhile, maybe I can ask my own questions to Arman. About the technologies. I'm just thinking about the map and YEKA regions, 1,000 kilowatt of high tension grid, let's assume. So it is polar, a minus and a plus. Yes, we can bring it to Istanbul. 1,000 kilowatt of line it is. So in case of a problem, should we have an alternative line, for example, for the ACC systems, for example? I remember that we always have the alternatives for the DC systems. Should we have an alternatives? What would it mean, for example, for the investment cost in case of a problem while converters, what would happen to them? So should we cut the renewable generation? So could you please share your insights about the operability of the system, please?
Yes. So important to say is that for that big amount of power we are speaking, so when we speak about 2 giga links or 3 giga links, we nowadays refer to bipolar topology. And in bipolar topology, what happens is that in case of fault on one of the lines, still the system can reconfigure itself through the ground, and you keep half of the power active. So that means that the loss you have in most of fault cases will be only of half of the system. Moreover, let me say that one of the limitations of the technology, so what we are targeting today in Europe are links of power of 2 giga. And that power is not a technical limit of the converter technology. It is a technical limit of the DC cables because of the ampacity of the DC cables, especially in submarine environment. And secondly, it is also depending by limitation to the grid, because the grid often cannot afford to lose 2 giga, or more than 2 giga at a time, to keep the stability. So that is the first part of my answer. Then, of course, in the plans, and in the plans which I have seen, let's say, looks that whoever has been developing the plan has been planning several lines connecting. So even in case of failure of one of those, there will be different routes to feed the main consumption points. But let's say the first part of the question, I guess, already answers your warning.
Yeah, thank you very much. Yeah, more clear. Yeah, and bir bipolar technology enabling, belki Türkçe'ye geçmem daha doğru olur, sorry. Bipolar
Bipolar technology, HDVC carrier technology. I think that they have an advantage. In case of a failure on the transmitter, while the cutters, when they open it, just let's assume that it still can carry the power underground. These contactors, conductive contactors can do it, and it is a great advantage. We should know this. We should actually design the grid accordingly, I believe. Well, is there any other questions for TEAS, for example? HDVC technologies and the scenarios have already been studied, right, by you. So this is how we understand and what we understand. So, well, do you have any plans or requirements? What do you think about the AC and all? What would you say? So, is there any difference, anything that you feel maybe disturbed? Is it easy or is it difficult? Do you have any concerns? What do you think from the planner perspective, especially when we just think of the new technologies and the systems? Well, 80 gigawatt is the integration target level for us, and our consumption level is not that far away from it. So that's why AC solutions is what we are focusing on. However, we have new policies such as 120 or more than this. So this is the project dimension. And we have 600 kilometers actually maybe distance that you have to carry it. So in the coming days, in the Aegean region, yes, the plants are to be shut down, for example. So if this is the case, the east and the west axis should be empowered. We cannot do by using AC because of the reactive capacity. the reactive capacity consumption is really high, and the DC systems, in terms of reactivity, yes, they also contribute. Well, they correct the tension, so that's why ACV it is a positive contribution. Actually, it is a positive contribution, and it is good for the integration. However, we need a long-term planning. So, transformers, yes, we have a system for them. We have a management system for them. However, for the other systems, now we organize workshops, strategic plan, short-term strategic plan. Even in the morning, distinguished minister has talked about that. On the first plan, we are just focusing on 10 gigawatt. This project is more concrete. So by using as well our specification experience and operation experience, we are planning to implement this long-term policy. However, as I've told you, our target is 100% renewable. If you do not have this target of renewable energy, then it won't work, because you don't have to carry the electricity from one point to another point. So it is parallel, HPVC, in parallel to the renewable energy means. Well, thank you very much. We are over our time, by the way. This is the end of the session. Poline, in their policy proposals and recommendations, they have declared that there is an interest, but it is still early. It sounds really interesting. There is now an intensive for natural gas sources. For the renewable direction that we walk through, but still we give incentives for the natural gas, then it would probably mean that the energy that will be used is this. So when we look at the plan and when we are to look at the natural gas, yes, it has an important place. We cannot give up on them because on the grid it gives us a certain flexibility. It just gets rid of the loading and uploading, and as it has an inertia and kinetic energy, it is very, very valuable. Natural gas plants, they are green and they are really valuable. I'm sure that Mr. Kazım will confirm what I say. So, yes, we have the rotating mass, and they are part of the grid. We don't want them to leave the grid because it gives us a great somehow energy. So this is it is a source of energy, by the way. So natural gas plants, their numbers would continue to be the same. So about the policy proposals for the hydrogen, we might think of maybe more maybe concrete issues. Hydrogen is expensive. We don't have it in many places. Producing it and generating it, of course, will bring a loss of energy on that regard. So when I see this policy, I also had some question marks in mind. Would it really happen? These natural gas plants, would they in reality would work and all? So economically, while turning them or changing them to the hydrogen, it is not that possible. But as you have said, we have base load, which is a natural gas plant, and it gives us a certain flexibility. So that's why I would say that we are now trying to create an alternative, and this is what we decide on. In Germany, we have carbon capture technologies. This is what it was decided. distinguished minister also well have talked about this. He has some certain doubts and concerns, but we will start doing it as well somehow. Because when we just think of the emissions, carbon emissions, this is one of the most important target, and it decreases the carbon emissions. However, we can maybe look for an alternative. However, for the economic terms and in terms of economic efficiency, well, we don't know how it would be. Let's see what will happen. Okay, thank you very much Dan, for your kind contribution. For the final time, I'll ask it to our distinguished participants if you have any questions or not. I guess not. So thank you very much for your participation. It has been a really informative panel. Thank you very much for listening, for participating, and thank you for being here with us. And as well, we have friends from TREP. So we are closing, right? This is the end. So we can close, I believe, the session, right? We have now a little closure ceremony. I would like to invite here Mr. Serdar, please, to the stage.